Now that we've talked about structures and enumerations in Rust, it's time to start talking about collections. Now, the first part of collections that we're talking about in this part of the video are tuples. And we've touched upon tuples before, but I just want to quickly go through them because we talked about creating tuples, but we really didn't have a look at how to unpack tuples. So tuples are unnamed groups of data. So we saw, for instance, a circle could be defined as a tuple of its center point and its radius, and all the points and all the values stored inside a circle could, for instance, be unnamed. So you could, for instance, create a tuple. So you could create a tuple of point, and you could just say you have an F32 of F32 values in here. So this could be its X and Y points. So it's kind of like implicitly stated that this is the X and Y points of X and Y places, or the point of this point. So tuples are heterogeneous collections. They're kind of structures on the go. And you could even create tuples on the go. So you could, as you can see at the bottom of the screen, you can say values are hello in here, hello, and then world. And then you could also say, I should close the string as well. And then you can put a value of 30 in here. So you can see in here, we just created a tuple of string slice, and I32 on the go. Now that you have access, now that you have created your tuple, you can unpack its values using the index of those values. So you could say let hello is values 0, let world is values 1, and let age is, for instance, values 2. Values.2. So this is how you would unpack the values inside your tuples. You could also unpack them in a group. So you could say let hello, world, and age all are equal to values in here. And that's how you would unpack the entirety of this tuple on the go. And you can do this in some other languages, such as, for instance, JavaScript. Now, if you're only interested, for instance, in the age value, and you want to use this unpacking syntax in here, you could say let underscore underscore, basically ignoring the values, and age equal to values. And what happens in here is that only age is going to be unpacked, and the first two values inside your tuple are going to be ignored in this case. You can also return tuples from functions. So you can have a function in here that returns this tuple, for instance. So you could say fn get values, and it has no parameters. And it returns a tuple of string slice, str, and I32. And inside the function, you could basically return this structure, or basically a tuple. And then you can grab those values. You can say values is get values, or you could just say let, for instance, hello and underscore underscore equal to get values. And in this case, only hello is going to be unpacked from this function. We're getting a little bit of an error in here simply because we're missing lifetime specifiers. So the way to fix that, for now at least, it would be to change these to strings, and then we will talk about lifetime specifiers later. So hello, and we say to string, and we'll do the same thing to string in here as well to fix the problem with the word world. Okay, so that's how you could return a tuple from a function as well. Now that's enough for a tuple unpacking at the moment. We can talk about vectors. Now, vectors are something that you may be familiar with from other programming languages, and in other programming languages they're called arrays as well. But in Rust, they're specifically called vectors, and they're two-dimensional arrays of data. You can specify a vector of fixed size in Rust with the syntax that I'm showing you at the bottom of the screen. So you can say, for instance, let values, and you can say I have string slices, 2 of them, and then you go ahead and say foo and then bar in here. That's how you would create a fixed size vector of string slices. So you specify the data type of the values inside a vector, and then you would also specify the number of elements inside that vector. Now, you can iterate over values inside your vectors. So you can basically loop through them, as you may call it in other programming language. So you'd say for value in values.iter, okay? And then you could say print value. And let's go ahead into the terminal, and you can see the values of foo bar being printed to the console. Now, if you want to read values at specific indexes and get the references, you can see in here we have values. You can go ahead and basically say let foo is values at index of 0. So you get a reference to that string that's placed inside that vector at that particular index. And then you can print ln foo is, and then you would say foo. Okay, so that's how you would get a reference to a value inside your vector. Now, if you're interested in the length of a vector, you can always get that with the len function, as you can see at the bottom of the screen. So you can say values len, and that will give you the length. And in this case, this length is, of course, 2, because this is fixed length array or vector. Now, you can also do mapping. So for every value that inside the values vector, you can map those to some other value. So mapping iterates over an iterator, or a vector in this case, which is an iterator. And it will basically allow you for every value to return a new value, such as, for instance, the length of that string. So let's have a look at that. So in here, let's go ahead and create a vector of values, and we call it, this is I32 with length of 2, and we put the values of 10 and 20 here, and we say values, and then we create an iterator out of that, and then we map them, as you can see in here, and we say for every value that comes in, then we want to calculate, for instance, that value multiplied by 2. Okay, and this is the syntax of creating basically the mapping from one vector to the other. So we say doubles or doubled, we could call it. Okay, and that's how you basically map one collection into another one using the map function. Now, there's also a shorthand for creating a vector, so you don't have to specify the vector data type and its size. So it's not fixed length, and that is using the vec macro in here. So you'd say values is equal to, you say vec and an asterisk in here. That's not an asterisk. What do you call? I've forgotten the name of this. It's not an apostrophe. In Swedish, we say utropstecken, but I've forgotten the name of it. Let's see if I can find the name of that. I can't find it. I've lost the word for it. And then in here, you can create your vector, as you can see at the bottom of the screen. So you can say you have a new vector, and its size is not known in this case when you use the vector macro, basically. So you provide your values and separate them with a comma, and then use the vec, basically the vec macro in here to create your vector. Okay, you can also create mutable vectors, because when you create vectors like this, they're immutable. But in Rust, creating mutable variables is very simple. It's just you add mut after your let to create a mutable vector. Okay. Now that you have mutable vectors, you can actually push values to them when they're not fixed size vectors. You can see values push 4. This allows you to push a new value to the end of the vector. Okay, and also you can pop a value. So this 4 is values.pop, and this is gonna remove the last value that was inside the vector and then return it to you. It's returning that value as an optional value to you, which is specified in Rust as option, but we haven't yet come to the chapter in this video, in this course, where we talk about optionals. So let's wait until we get there before we talk about option, okay? So I should have brought up the title for this section before, but that's how you basically do popping of values in vectors in Rust. So you can also remove all values from a mutable vector in Rust using the clear function. So you would say values. So if I say println values are, and then we say values, and then you say values clear, and then you do the same statement in here. If you then bring up your terminal, you can see first values are 1, 2, 3, but after doing clear, the vector is cleared, as the name of the function indicates, okay? So you can also clone another, this is a little bit more advanced to discuss right now, but you can, if you have two vectors, for instance, you can clone a vector and then place its contents inside another vector. So you can in here see that we have values. We print its contents, and then we say values dot extend from slice, and then in here we create a new vector, and you can see replaces contents we add the contents of this vector to the end of the values variable. So if we bring up our terminal again, you can see first values are 1, 2, 3, but then they're going to be extended with 4, 5, 6. This is a nice way of adding a whole new vector to the end of your own vectors as well. So there is a concept of moving. We talked a little bit about ownership, but you can move contents from one vector to another. So if we say let mut values 2 is a vec of, let's say, 4, 5, 6 in here, okay, 4, 5, 6, and then we say values 1, and let's remove this println. So values 1 is that, and values 2 is this. Let's do a println now, and we say values 1. Values 1 is this, and then we print the contents of values 2 as well. But if we want to move the items from values 2 into values 1, then you would say values 1, values 1, and then you would say append, and then you would put your mut reference in here, mutable reference, and then we say values 2, okay? After doing that, we can print the contents of values 1 and values 2 in here. So values 1 and then values 2. And we're going to have a look at our terminal. You can see values 1 in the beginning and values 2 are correct as they were supposed to be. Values 1 after doing the moving is containing basically the contents of values 2 as well. And after the moving happens, values 2 is pretty much cleared. So that's how you would move contents from one vector into another one. Now, if you want to see whether a vector has a value placed inside it, you could say if values 1 contains, and then you would say the reference to the value of, for instance, 3, and then you'd say yes, and then otherwise no. And in this case, we're going to get the value of yes because our vector does contain the value of 3. So you can use the contains function for that. Now, you can also see whether a vector is empty by using its isEmpty function. So you say if values 1 is empty, then you can print some statement here, values 1 is empty. And if you do this vector, which is an empty vector, basically, let's see, vector, we could actually specify this the type, but I'm not going to do that right now, but we could do a clear on it. So you could say this is a mutable vector, excuse me, and values 1, clear. And then if it's empty, okay, and now we're going to see the values 1 is empty because we did a clear on it. So if you want to see whether a vector is empty, you can use the isEmpty function on it. After talking about vectors, now let's talk about HashMaps. HashMaps, they're also called dictionaries in some other programming languages. They're key value collections, basically. Now, in order to use HashMaps, they're not a part of the std libraries already included values. They're not in the prelude, as it is called. So you have to use a use statement. So let's say use, excuse me, std collections, and then we're going to say HashMap. After you have included HashMap in your file, then you have access to HashMaps inside that current file. So after creating an instance of HashMap, after going ahead and using HashMap and importing into the current context, we can go ahead and create a new HashMap actually in here. So let's say values, and then we say this is a HashMap and of string slices str and str, and this is equal to HashMap. And we create a new instance of it. So Rot's analyzer is giving us a warning simply because we haven't used this variable, but this is completely fine for now. So the way to insert values inside a HashMap is using the insert function. So a values insert, and then you insert your values in here. We say foo and then bar in here, as you can see, okay? And then you can actually print the contents of your HashMap to the console. So what we're getting here cannot borrow values because it's not mutable. So let's just make it mutable. All right. And then we can insert values into it, and then we can println it. Println and values. So let's have a look at the values in here, terminal. And you can see for the key of foo, the value is actually bar. So if you want to check whether a HashMap contains a specific key, you can use the contains key function. So we say if values contains key, okay, name, as you can see in here, And then you can do some code, values name. Otherwise, we say no name, and say println exists. Otherwise, we say no name. And you can see we're going to get no name because the key of name doesn't exist in our hash map. Now, if you want to remove a specific key and its value from your hash map, you can use the remove function. So here we have the foo key, and then we say values that remove, and then we say remove foo, basically, from our hash map. And if we print ln our hash map again, you can see it is empty. So it doesn't contain any keys or values in there because we removed the only key that does exist or did exist. Now, if you want to unsafely read values from a hash map, meaning that you're assuming that the key for that value exists inside the hash map, you can just refer to the key of that value. So we say let bar is values, and we say values, and we say the key of foo. Okay, so if you say println bar is, and then we say bar in here, and have a look at the terminal, you can see bar is bar. However, this is quite unsafe because if you misspell, for instance, your key in here and you say foo, you can see then you will get a panic in here. And so this is not a good idea. That's why it's unsafely reading values from HashMap, as you can see at the bottom of the screen. If you want to safely read values from your hash maps, you can basically use this function, which is called get. So we say let bar here is get values, get foo, and this is now going to be an optional. We haven't talked about optionals yet, but we can actually use a match statement in here. So we say match values, get foo, okay, and now we have to write code like this because we haven't talked about optionals. I'm not going to explain it, but I'll just quickly say what it is. In case that value for that key does exist, then this part of code will be executed. Otherwise, the none part will be executed. But I just don't want to go too much into optionals right now because there is a separate section of this video that we're going to talk in details about optionals. But just know that you can use the get function on your hash map in order to safely read the value of a specific key from your hash maps. Okay. Now, you can also iterate over values, keys and values inside your hash map. So you can say for a reference of key and a reference of value in values, and then you can print them to the console. And you can see in here, try Rust to explain what happened in here. Let's see. It doesn't have a size known at compile time. That's fine. So the value in here, the key and value, let's see what happened in here. The key and a value in, okay, because I didn't get a reference to values. That's fine. We're getting a reference to the values hash map, and then for every key and value, we're getting references to those keys and values, so we're not actually moving the values during the iteration. That's very important. We've already talked about ownership before, so you should know about this by this point. So this is how you would basically iterate through a hash map as well, using the for in syntax in Rust. If you want to retrieve a specific entry inside a hash map, meaning its keys and its key and value, you would use the entry function. So you'd say let entry is values.entry, and the key is foo. And you can see now this is going to be your entry of string and string. Okay, and an entry has a key and also value. Actually, key, it has, what does it have? Entry.key, and it has also a lot of properties in here. Oh, it has into, which is going to give us the value. So it's really good. So that's how you would get your entry from your hash maps as well. But to be honest with you, usually entry is not used, at least in my experience, that much. Sometimes you may need it, but if you're manipulating a hash map, usually you just go ahead and like read the keys with a match, or you will add some key to a hash map if that key doesn't exist, for instance, and stuff like this. But entry is rarely used. So if you want to match an entry, you would basically go ahead and say match entry in here. Okay, missing match arm occupied. That's fine. And you can see in here for the entry of occupied, if that entry is available in the in the hash map, then we're basically executing some code, but it doesn't necessarily have to be this. Otherwise, we're doing something else. This code, to be honest with you, is not that important at the moment for you to know about because entry isn't itself that often used, but just know that you can actually match an entry against a city collections hash map entry occupied if there is a value in it. Actually, we don't actually need to get it as an occupied value in here. We could say value, and then we say println value gets. Otherwise, we do this, and we can just execute our code as well. Have a look, could not compile. Let's see what we're doing wrong somewhere in this code. Let me clear this code actually and run our code again. And we're getting some error. You seem to be trying to use match for destructing a single parent because they're using if lets. Okay, so this is basically this is Clippy telling us that we're doing something quite stupid in here, and we could just use a println in here and say not found. So maybe Clippy will be happy after that. So you can see the value of bar being printed to the console. Okay, now you may be also trying to insert some values inside your hash maps only if the key for that value doesn't already exist. So in this case, for instance, we have the key foobar. Let's just change this to name, and then we say John Doe. Okay. Now you can say values entry, okay, of name, and then you say or insert, and then you would say Jane Doe. Okay, so what this does really, it looks at the entry of name, and if it doesn't exist in the hash map, then it inserts that name entry into the hash map with the value of Jane Doe. So if I in here said husband, and then in here I said wife, and wife doesn't exist in values at this point. So wife will then be inserted with a value of Jane Doe. So then we can println the contents. Then you will see it will contain both the husband and the wife keys in the hash map. All right, that's great stuff. Now, if you want to insert custom structures inside your hash map so that you want your structures to actually be placed inside a hash map, for instance, if you have a person structure, so let's say struct a person, and then this person has a name and an age. If you want a hash map of, for instance, person and then their ages, or a person and their addresses, so let's just say a reference to a person, or we say person instances, okay? And you will see now that this person, actually this does seem to be working fine, but you need to make sure that your persons are able to be inserted inside a hash map and that they're hashable. And the concept of hashable is something that we're not going to go too much into details about right now, but just know that hash maps in Rust and pretty much all other programming languages that have hash maps, they use like hashing algorithms. And a hashing algorithm is kind of like an algorithm that turns a structure instance, for instance, into its numeric representation, a unique numeric representation, so that that person with a given data is unique inside the hash map. So two persons with the same name and age, then they're going to have the same hash value, meaning that if I create a person with the name of John Doe and the age of 30, and another person named John Doe with the age of 40, and insert that person into the hash map, then that person is going to replace the previous person, simply because, for instance, if we calculate the hash value of a person using only their name, then that means it's the same person. So the hash value is a numeric representation that uniquely identifies a value. And if you want Rust to calculate that hash value for your custom structures, you can derive that, as we've seen before, with a few traits, hash equal with EQ, partial EQ, and you can also use debug. So now you can insert your values inside your hash map without a problem. Now that we've talked about hash maps, let's talk about iterators. Actually, I moved past this quite fast. That's simply because it's not so relevant to the concept of hash maps, but I just wanted to bring it up for you so you know about the concept, okay? All right, now that we've talked about hash maps, let's talk about iterators, because they're kind of like, I mean, I've placed them inside the collections section of this video, but they're not really collections in that case. It's just that they belong to collections, okay? Now, the iterators are kind of like a list of things that you can go through, and then you can consume them. Now, iterators in Rust, as in many programming languages such as Dart, are lazy. You actually need to consume an iterator for it to actually do something. And we'll see an example or a few examples of this soon. Now, iterators in Rust, they're using a special trait called iterator, and we haven't really talked so much about traits. We've only talked about the debug trait, and we've had a EQ, partial EQ traits as well, but we haven't really gone into details about it, and that's because I'm going to talk about traits in a completely separate section of the video, and we're going to go into details about it. So I don't want to go into details about traits in this particular section, but just know that there is a special trait placed on iterator, or iterator is itself a trait. And when you do a for loop in Rust, Rust automatically understands that an object is an iterator, and it consumes the iterator for you, so you don't have to consume it manually. Okay, so let's go ahead and create let values in here and create a vector. For instance, I'm just going to say this is a vector, vec. Okay? And if you want to iterate through this, the values inside this values variable, you would say for a value in values.iter, okay? And then you can print them to the console. You can see 1, 2, 3, 4, 5. So this is how you would basically create an iterator out of a vector using its iter function. Now, iterators, they have basically functions on them as well, because iterators, they're a type. So if you say iter is values iter, okay, you can see it is an iter of i32, and you can get the sum of the values inside this iterator using a sum function. It's a function that is placed on the iterator itself. So you would say sum1 is iter.sum. You can see in here, okay? Great. Actually, see type annotations i32. Okay, so now that you have the sum, but if you try to calculate the sum again, you will see an error in here saying use of moved value iter. So what's happening is that by doing a sum in here, this sum function on the iterator is consuming the iterator, and that simply means that it has gone from the beginning of the iterator to the end of the iterator and collected all its values and summed them up and brought that value into the sum1 variable. Now that the pointer of the iteration is at the end of the iterator, it means that the iterator has been consumed. So you cannot collect the sum again into a new variable. So that's something you need to understand about iterables in Rust, in that they are consumables, meaning that once they have collected the results, they're done. But you can go ahead and create another iterable in here. So you could say iter2 and then collect the sum from iter2. As long as you create new iterators, then you're good to go. Okay. Once you have iterators, you can actually map the results. So you can say values iter. Okay, and then you can map the results. So you can say x, and then you can say, or v, as you can see at the bottom of the screen, and we say v multiplied by 2. Okay, so let's foo. And you can see now this is a map of iterator of i32. So it's actually quite a complicated data type, all right? And that's really not what you wanted. You actually wanted a vector of i32, because your mapping is taking i32s and doubling them. So how do you collect these values? The way to collect these values is using the collect function, not so surprisingly. So let's call this multiplied by 2. And then at the end of this, you would say collect. And then you will basically collect the values. I think we're missing a data type in here, type annotation. And let's go in here and say this is a vec i32. Great stuff. So now that we've collected that, we can actually print the multiplied by 2 values, and you can see it will be 2, 4, 6, 8, and 10. So the collect function basically takes an iterable And as you saw earlier, it wasn't actually an iterable. It was like a map. So it takes that map and turns it into an iterable for you. Okay, so when we talk about iter, you know that it goes through references. So when we had names in here, names, we can say it's a vector. And let's see, John, Jane, blah, blah. So you can see that this is a vector of string slices. And we say for name in names, okay, names iter, okay. And you can see then, println name, you can see that name is a reference to a string slice. So when you say iter on any collection, then you're basically working with references inside that collection, although the vector itself contains string slices, which themselves are kind of like references, okay? But if you want to get owned values, in that the values are moved from the iterator out into the iteration itself, then you can use the into iter function. So iter, we say into iter instead. And now you can see basically your values are being unwrapped for you. So you're getting owned values out of your iterator, okay? You can also use a filtering in your iteration. So you, for instance, may want to collect names whose length is only 3. So John, Jane, and Mary will be filtered out, and Bob and Tom will be filtered in. So they will be included in the result. So you can say into iter, filter, and then you will get your predicate in here. We say name, and we say as long as the length of the name is equal to 3, okay? And then you'll see the result will only include Bob and Tom. So that's how you would do your filtering using the filter function, okay? Now, you can also iterate over maps. So like HashMaps, we've already talked about this. So we can, if you have a hash map of like names and values or keys and values, you can use the for loop to also go over them. And that's also basically doing an iteration. Just talking about iterators, I thought to bring that up. Now, you can also jump over iterations using the continue. So for instance, in here, if we didn't do the filter in here, and we could just go into the iteration itself, you can see at the moment it's printing all the values. So it's John, Jane, Mary, Bob, and Tom. But if inside this iteration, you want to jump over the values, the strings whose length is more than 3, you could say if name len is not 3, then we continue. So using the continue statement, you can jump over an iteration. If you run this code now, you can see only Bob and Tom are printed to the screen. Now, if you want to break out of an iteration, so now that we're inside an iteration, you want to break out of it, such as soon as you detect the name Jane or any name that is 3 characters in length, you can basically then jump out of the iteration using the break statement. So if you say, if the name is 3, then break out. So what happens is as soon as we detect the name Bob, which is 3 characters in length, then we're going to jump out of the loop, and Tom is then going to be left out of the iteration. So if you run this code, go to the terminal, you can see John, Jane, Mary, and also actually, yeah, since we detected Bob as well as length of 3 and we jumped out of the iteration, Bob isn't going to be printed to the console either. So if we brought this print statement up, actually, no, let's not do that, because if you bring the print statement on top, everyone's going to be printed anyway. So this is how you would break out of an iteration. So that's quite short about collections. We talked about tuples, we talked about vectors, hash maps, and iterators themselves. And there's a lot more to iterators and all these collection types, and we'll see examples of them as we go through the various videos in this course. But I hope you enjoyed this part of the course, and I'll see you in the next one.